everyone. Welcome back to the course Introduction to Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. In the last lecture, we discussed about different sustainability considerations in infrastructure management. This is the third lecture where the focus is on resilience considerations in infrastructure management. My name is Chirag Kothari. I am a faculty in the Department of Civil Engineering at IIT Kanpur. Let us start our discussion with developing an understanding of what is resilience. Resilience, I am sure most of us have heard this term in the context of material science. In material science, resilience meant that a material's ability to absorb impact, that is, the property of that material to absorb energy of an impact without permanent deformation. So, this is how resilience is defined in material science. In different contexts, resilience is often defined either as an objective or as an outcome or as an ability or as a capacity. For infrastructure, resilience is generally known as a measure of capacity. The United Nations Office of Disaster Risk defines resilience as capacity of a system or community at risk to absorb, adapt, change and withstand the results of hazard in a timely and efficient manner, including through conservation and the reconstruction of its structures and core functions through risk management. Let us look into some of the key terms in this definition. As I mentioned, resilience is a measure of capacity. So, the way resilience is defined is it is a capacity of the system to absorb. So, that is you want to absorb the impact, then to adapt, change and withstand the results of an hazard, and this must be done in a timely and efficient manner. This could be through conservation and reconstruction. We will discuss some of these terms in detail in this lecture. Let us break down this particular definition and see it from a different lens. Resilience, when talked about in a comprehensive manner, includes risk reducing strategies for the following aspects. The first one is risk reducing strategy before the event. So, before the hazard or event has occurred, you want to reduce risk. Second aspect is coping on time or facing the event in a efficient manner. The third aspect is efficient post event response. Once the disaster has occurred, how efficiently can we respond after the event. Fourth is efficient recovery measures, how quickly we can recover our assets again. And finally, how well can we adapt and transform so that in future the impacts of such events can be reduced. So, a comprehensive resilience approach includes different aspects of risk reduction before the event, during the event, after the event. In case of after the event, you want to ensure that there are recovery measures in place so that the infrastructure can be recovered quickly. Moreover, you want to adapt and transform so that in future the impact of such disasters can be reduced. Resilience thus deals with maintaining and enhancing the ability of a system to absorb, adapt and recover. In order to understand the concept of resilience, we must understand one another important term, which is vulnerability. And before we discuss vulnerability, let us discuss what is the difference between an hazard and a disaster. Are these two terms different or are they same? Please pause the video, think about it and then please proceed. Hazard, as we define it, is a dangerous or risky situation that has the potential to cause a disaster. That is, any event which is risky or dangerous and has potential to cause a disaster is a hazard. Next, disaster is the actual negative impact that occurs when the hazard actually happens and it significantly harms the community. So, I hope the definition of hazards and disaster is clear. Hazard is just a risky situation that has the potential to cause a disaster. On the other hand, disaster is the actual negative impact which is faced by communities when the hazard actually happens. To better summarize this, we can say that the likelihood that a hazard would lead to disaster is governed by the term vulnerability. That is, if you have a system which is highly vulnerable, then the likelihood of hazard becoming a disaster is very high. On the other hand, if you have a system which is not vulnerable, then a potentially risky situation or an hazard will not lead to a disaster. That is, it will not significantly harm the community. Now, let us focus on different ways of understanding vulnerability. One good way is to divide it into three aspects. The first one is physical fragility, second one is socio-economic fragility, and the third one is lack of capacity to respond. The first one, which is the physical fragility, means that the infrastructure, the human settlement or the structure under consideration itself is vulnerable. It is physically vulnerable and it cannot withstand the impact of a disaster. This is physical vulnerability or physical fragility. The next one is socio-economic fragility. This means that in addition to the physical infrastructure, if there are some disadvantageous conditions, if there are aspects of social segregation, or if there are vulnerable populations which are more vulnerable. The second aspect of socio-economic fragility deals with the community. Any disadvantageous conditions, different aspects of social segregation or presence of vulnerable communities define the socio-economic fragility. The idea here is that vulnerable populations are more susceptible to a hazard in comparison to the other members of the community. The third aspect is lack of capacity to respond. In this case, we focus on the ability to mobilize resources so that the impact of hazard can be reduced. So, the three dimensions of vulnerability are focused on physical, that is the infrastructure itself, second the socio-economic, the community, the people around it and the impact of infrastructure on these, and the third one on the capacity to mobilize enough resources to absorb the impact of hazard. These are the three dimensions of vulnerability. They can be understood with the help of this particular flow chart. So, say there is a hazard. As we discussed, hazard is a potential event which might occur. This hazard, whether it will become a disaster or not, will depend on the exposure. Exposure in turn will depend on two aspects: physical vulnerability, that is the infrastructure itself, and social vulnerability, which includes the communities, the societies, the people, the biodiversity, etc., which will get impacted because of this hazard. So, the exposure is defined by both the aspects, physical vulnerability as well as social vulnerability. Next, we try to understand the exposure levels as well as the intensities of hazards to do a comprehensive risk assessment, where we are trying to understand what will be the potential impact of this particular disaster if it happens, and accordingly we come up with different risk management strategies like prevention, reduction, mitigation, etc. However, we cannot be successful always, and there will be cases where these hazards will actually lead to disasters. Disaster can be considered as the impact of this potential hazard. Once there is a disaster, the focus shifts to disaster management. That is, once the disaster has occurred, you want to ensure that the impact of the disaster is reduced and you can recover from this disaster quickly. So, I hope the aspect of vulnerability is clear, that it focuses on both the physical vulnerability as well as social vulnerability. The idea I want to communicate through this particular discussion is summarized in the following sentence. That is, in addition to infrastructure resilience, that is the resilience of the physical infrastructure, we also need to tackle socio-economic conditions. In doing so, it is possible to increase the resilience of the communities to cope event, quickly recover and build stronger to avoid future disasters. Having discussed the concept of hazard, disaster and vulnerability, let us move back to the idea of resilience. Resilient decision making for infrastructure includes two aspects. The first one is developing or building resilient infrastructures, and the second one is developing or building infrastructure for resilience. These are two sides of the same coin. In the first one, the focus is on ensuring that the infrastructure which we create is resilient. So, the focus is on assets resilience, that is the physical strength of the components. For example, can the bridge withstand the earthquake? Or service resilience, the ability to maintain the service. Can the power grids reroute electricity if the line goes down? And so on. So, in the first aspect, the focus is on making the infrastructure resilient. On the other hand, the second one is developing infrastructure for resilience. This aspect goes beyond the infrastructure under consideration. It focuses on broader societal benefits, where the question is, do you have enough infrastructure to ensure community well-being and economic stability during the crisis event? Moreover, do you have systemic resilience, that is, does it help in managing large scale risks like climate change? So, I hope the concept here is clear that resilience includes both creating resilient infrastructure and creating infrastructure for resilience. Moving on, let us discuss why do we care about resilience? Why do we really need a resilient infrastructure? Why are we concerned? The infrastructure which we have is always under stress. This is a key challenge which we need to adhere to. The systems are always under stress. This stress can come from several reasons. Our infrastructures have to face a constant and growing array of threats which can cause them to fail. Let us discuss some of the reasons for these stresses. It can be things like natural hazards, for example, earthquakes, floods, cyclones, landslides. Each of these impact our infrastructure. They put stress on our systems. Second, there can be aspects of climate change, rising sea levels, extreme heat, droughts, etc., which again stresses our systems. Additionally, there can be systematic shocks like pandemics, supply chain collapse, financial crisis, and so on. Additionally, there can be man-made threats like cyber attacks, physical attacks, human errors, and so on, which again stresses our infrastructure. Moreover, the main issue is that there are cascading failures. One system is connected to another system. These infrastructure systems are often interconnected. Thus, failure in one system often cascades to another. For example, a power grid failure can knock out water supply, it can knock out communications, it can knock out transport. Thus, one failure, a failure of a power grid, can have a domino effect impacting water supply, communications, transport, and so on. Thus, our infrastructure systems are always under stress, and these stresses have been increasing continuously. Let us look at some of the examples which prove this point. Humanitarian emergencies linked to climate change, such as heat waves, wildfires, floods, storms, and hurricanes, have become more frequent, severe, as well as costly. Moreover, all these have disproportionately high impact on vulnerable populations. The number of vulnerable populations have also increased. Moreover, another important aspect which should make us more conscious about resilience considerations is that 60% of the infrastructure which we will need in 2050 has not been built. That is, in the next 25-30 years, we are going to construct a lot of infrastructure. This is our opportunity that we ensure that any new infrastructure which comes up is resilient. The decisions we make today will define the world for decades to come. This aspect can be communicated really well with the idea of resilience dividend. Let us discuss what is resilience dividend. It says that investing in resilience isn't just a cost, it is an investment with a significant return. It is believed that every $1 invested in making infrastructure resilient yields an average of $4 in benefits. The question is, how do we define these benefits? How do we say that every $1 invested in making infrastructure resilient leads to a benefit of $4? The idea here is that in case there is a disaster, there will be loss of lives, there will be economic losses and disruption of services. If you have an infrastructure which is resilient, then you can save lives, you can ensure economic gains or at least no economic losses, and you can ensure continuity of services. The resilience dividend can be defined as follows: the value of reduced future asset loss, avoided service disruption, wider social, economic and environmental co-benefits, and reduced systematic risk that occur over the life cycle of an infrastructure system is known as the dividend of resilience or resilience dividend. This definition is available in a report by CDRI. I'll talk briefly about them in one of the slides later. Therefore, resilience is an important aspect in infrastructure decision making. There have been both global as well as local efforts to improve resilience of infrastructure. Let us look into some of these efforts. For global efforts for climate compatible infrastructure include the following: OECD, that is the Organization for Economic Cooperation and Development, has urged governments worldwide to strengthen strategies for developing climate resilient infrastructure. A global coalition named as Coalition for Disaster Resilient Infrastructure (CDRI) was founded by India to advance discussion on disaster resilient infrastructure across various sectors. Moreover, the Global Center on Adaptation (GCA) has developed a comprehensive climate resilient infrastructure handbook. There are several global efforts which emphasize the need to include resilience considerations in infrastructure. We want to ensure that the infrastructure sector aligns with the global resilience call. In this regard, different efforts taken by India include the following. First one, as I mentioned, CDRI. India spearheaded the establishment of this organization in 2019. It was launched by the Prime Minister of India at the United Nations Climate Action Summit. This organization has been fundamental in advancing the efforts toward making our infrastructure resilient, which includes technological interventions, capacity building, education, developing communities of forums, etc. Moreover, India's action plan on climate change highlights the need for climate resilient and climate compatible infrastructure across sectors. So, our policy documents acknowledge that we should have aspects of climate change in our mind when taking appropriate decisions. Additionally, there is a urban infrastructure resilience program which is governed by CDRI. It helps countries integrate climate and disaster resilience into infrastructure planning, operation and maintenance by augmenting investments for sustainable and resilient urban growth. After that brief discussion about what is resilience and why should we care about resilience, let us look into how this is integrated with the idea of infrastructure asset maintenance. Resilience in infrastructure asset management. As we have seen, asset maintenance can play a critical role in preserving and extending the life of an infrastructure. This is generally under normal operating conditions. However, also during extreme conditions, if you have an infrastructure which is maintained properly and preserved, one can ensure that the impact of disasters can be reduced. Thus, what I want to communicate here is asset management can play a critical role in improving the capacity of the infrastructure to absorb, adapt change and withstand the impact of a hazard. Proactive, timely maintenance during normal operating conditions can support resilience efforts during disaster. Increasing urbanization, growing population, and rising needs have put excessive pressure on the existing infrastructure. Because of that, it has resulted in faster deterioration. This, coupled with extreme weather events, necessitates resilient asset management systems where the focus is on improving operating conditions, where the focus is on maintaining the assets both during normal conditions and during extreme weather events. In the previous lectures, we have already seen how an infrastructure performs under normal operating conditions. We have seen that for any infrastructure, the performance goes down like this, where on the y-axis I have performance and on the x-axis I have time. Now, let us discuss how does this performance curve change under extreme conditions. Remember, this was under normal operating conditions. Now, under extreme weather events, the performance curve looks something like this. This curve is available in one of the publications which was published in 2023. Let us look closely at this performance curve. First, focus on the dark blue line here. You will see that the dark blue line is drawn as a flat line before the onset of disruptive event. Now, there can be any event which can disrupt this infrastructure. The moment that happens, there will be a point where the performance of the infrastructure will start to go down. How much it goes down will depend on the absorptive capacity of the infrastructure. So, you see that the performance of an infrastructure has gone down when there is a disaster. Then there will be a point where the performance is minimum. Now, once the disaster event is over, we will see there are three possibilities. The first possibility is that the impact of disaster was so high that the infrastructure has completely collapsed. So, it looks something like this, which can be defined as the collapsing behavior. This is one situation which we want to avoid. The second possibility is that the infrastructure starts to rebound and it has restorative capacity so that it regains its original performance. This is known as the robust behavior. In addition to this, we also saw that you want the infrastructure to transform or adopt. Now, if that happens, it is possible that the infrastructure and the community learns from this disaster event, develops practices which makes them more efficient, so that now they are in a better position to adapt, and thus the overall infrastructure performance might even increase. This is known as adaptive behavior or adaptive capacity. So, thus one can assume that the infrastructure's performance will fall considerably during the disruptive event. If it falls, we want to ensure that it does not fall below the critical limit. This is where absorptive capacity comes into picture. Moreover, you want that the infrastructure should adapt to itself so that the next time event of any such hazards can be reduced. I hope these terms of absorptive capacity, restorative capacity, adaptive capacity, collapsing behavior, robust behavior, adaptive behavior, etc. are clear to you by now. Now, the question is, where does asset maintenance come into consideration? So, we have discussed how an asset typically performs under extreme events. Now, let us see how does this relate with the idea of asset maintenance. We saw that this is the curve for performance during extreme events, which is on the left side. Moreover, in this class, we have always seen that the performance even under normal operating conditions goes down with time. Thus, if we keep our infrastructure in a good performance condition, then hopefully at the onset of disruptive event, the overall performance is decently high and it does not fall below the critical limit. However, if there is no maintenance and say a disaster occurs when the performance is almost half, then here we might see a situation that since there is no maintenance done on time, the performance is already reduced, and now when there is a disaster event, the performance might fall below the critical limit, and that is the situation which we want to avoid. Thus, it is important that we maintain and preserve our assets so that its overall performance is decently high. This will help us in our efforts for creating a resilient infrastructure. We have already seen resilient infrastructure management includes setting up measurable targets, setting up different measures, how we will talk about resilience, monitoring and evaluating these targets, and taking informed and dynamic interventions. Now, in this case example, I will discuss how can different measures of resilience can be defined in the context of highways. Resilience, as we have seen from its definition, includes 4 key dimensions. The first one is robustness, which includes the ability of the system to withstand stresses. This is where absorb or withstand is coming into picture. Then the next dimension is redundancy, where we are checking whether there are alternate systems which are available which can work as backups or substitutes. The idea here is if there are alternate systems available, then the vulnerability of this particular infrastructure is relatively low. However, if there is no redundancy in the system, then the infrastructure under considerations becomes critical. Effectively, it also becomes more vulnerable. In addition to robustness and redundancy, the third dimension is resourcefulness, where the focus is on the capacity to identify problems, establish priorities, and mobilize resources when facing threats or disruptions. That is, if we have enough resources to deal with any hazard effectively, then we can say that we are resourceful. This is another important dimension within resilience. And last is rapidity, which defines how quickly can we act in a timely manner to contain losses, restore functionality, and also avoid future disruptions. So, I hope the concept of resilience and its dimensions is clear, where robustness, the ability to withstand, redundancy, the ability to have multiple backups, resourcefulness, the capacity to have enough resources, and rapidity, the ability to act in a timely manner. All these 4 aspects determine our resilience efforts. Now, let us discuss how we can define these in the context of highway. For a highway network, robustness may be defined as the quality and capacity of the road section. It can also be measured indirectly through seeing what was the length of disrupted roadways in the past disasters. Lower disrupted roads means the infrastructure is robust. So, in infrastructure decision making, you want to increase the quality and capacity of the road section, or you want to increase robustness. The second dimension of redundancy would include what are the number of lanes, what are the number of alternate routes available. This will drive how much redundancy is there in a system. If there are multiple alternate routes, it is ideal because effectively you are reducing the vulnerability of a disaster, because effectively you are reducing the vulnerability of an infrastructure system. Then the resourcefulness could include what is the location of a project. Is it remote or is it connected well? Moreover, are there local community members? Are they prepared? Are they ready to participate? Are equipments and materials available if a particular infrastructure under considerations faces a disaster? All these aspects are part of resourcefulness. And rapidity focuses on how quickly can we maintain the infrastructure, how quickly reconstruction or maintenance can be carried out so that the infrastructure is ready again. This also depends on are there protocols available for rapid decision making. If you have well-defined SOPs, then hopefully you can restore the infrastructure quickly or in a rapid manner. So this is just a small example of how we can define different parameters of resilience in the context of highways. With that, I would like to summarize this lecture where we have seen that resilience is not just an add-on. It is essential for preserving the infrastructure we build. Decision makers need to account for resilience when developing asset management plans. Similar to sustainability, this is a challenging task as it involves several objectives. Some of these objectives might even conflict with each other, or they might conflict with other performance or sustainability goals. Finally, in this context, multi-criteria analysis approaches and multi-criteria optimization has been found suitable for taking such decisions. However, as we saw in the last lecture, these methods need to rely on relevant experts to provide appropriate criteria weights. One needs to decide how important is resilience in comparison to sustainability goals, how important is rapidity in comparison to resourcefulness within resilience, and so on. Here are some of the references and suggested readings. Some of these documents are published by CDRI. I encourage all of you to look into it. Thank you. Thanks for listening.